We'll be looking into the topic of battery consumption in bioelectronics. This topic is important in the biomedical field and has the potential to allow blind patients to see again or disabled people to walk again. Batteries can cause many problems in implantable bioelectronics, and we will propose what we believe to be the optimal solution to address these problems.
Users: blind patients for retinal implants, deaf patients for cochlear implants, paralyzed patients for neural prosthesis, people who have pacemakers.
Bioelectronic implants require a power source. Batteries are bulky and are difficult to integrate into miniaturized implantable devices. Chemicals used in primary batteries are toxic and leakages can be harmful. There are many proposed solutions such as lithium batteries, biofuel cells, nuclear batteries, electromagnetic batteries, and rechargeable batteries. The battery technology that we choose must meet the following criteria.
Criteria: safety, power output, size, lifetime.
There are safety issues due to toxic material that can be used inside the batteries, which can cause harm to the patient. Another issue is the temperature of the battery. Batteries must transfer energy, which means they will inevitably heat up. If they heat up higher than the maximum allowed temperature of 2 degrees, they will not be allowed to be placed inside patients due to potential tissue damage. The power output and how it is controlled must be carefully considered when choosing a battery. If the battery is not able to supply enough power, it could render the implant useless and in some cases cause damage to the implant, which is only repairable by surgery. Also, if the power delivery of the battery is inconsistent, it could cause moments where the implant may not be able to perform its function. This would make the implant unreliable and frustrating for the patient. It can't be too heavy, as this could cause discomfort for the patient. The size must also be suitable so that it can be placed in the body where space is a premium. The amount of time the battery lasts without it having to be replaced is very important. If the lifetime of the battery is relatively short, it will need to be changed frequently, meaning the user will have to undergo regular surgery, which could lead to medical complications in the future. So ideally the battery should last the user's lifetime. Where this lifespan is not possible, the battery should be able to be easily and safely recharged.
By taking these criteria into consideration, we propose a solution that consists of a charging lithium battery paired with an independent battery system. The choice for the recharging technology is inductive charging, as it is relatively safe and has been used previously in many implants. Inductive charging works by having 2 coils, one inside the body and one outside. A high-frequency alternating current is passed through the coil on the outside. This causes a changing magnetic field, which causes a voltage to be induced in the second coil. The battery of choice are lithium batteries, as they have been used in many implants before, proving to be reliable, and have relatively high energy densities. For example, they can provide pacemakers with up to 10 years of lifespan. By choosing a combination of these 2 batteries, we can minimize the need for having to undergo surgery to replace the battery, which has its own risks, and allow the use without having to constantly worry about recharging.
As an example, if we assume the implant needs 40 microwatts, it needs 1260 joules per year. Using an average lithium battery, we estimate using our setup, the lifespan of the battery could be up to 34 years. Bioelectronic implants have the potential to transform lives, so we have to be sincere in improving the battery technology. We applied strict criteria to make sure that the battery is working efficiently so that the patient can have an improved quality of life, free from worry about the battery life and reliability. Although we propose a solution, we acknowledge that there are still many problems such as size and range of charging technology. That's why more research needs to be done to develop a battery that can change someone's life.